Okay, here is a little bit of help on the homework. I was asked about question number 5, so I'm going to start question number 5 and set it up, and then you're going to have to finish it. It says you have two angles. You have angle A and angle B. Now, if we focus on angle A is bigger than 90, less than 180, which they are telling you that if you draw this angle out, you're in quadrant 2, because quadrant 2 has the border of 90 degrees and 180 degrees. And here's angle A. And then you draw A. Now, this is going back to everything we've done from the beginning. If angle A is in quadrant 2, which we know, and the cosine, which is adjacent over hypotenuse, is 12 over 13, the adjacent side is 12, and the hypotenuse is 13, because every angle you drop an altitude to the x-axis, there's your triangle. So now you have to find the opposite sign. You find the opposite sign with the Pythagorean theorem. And the Pythagorean theorem should be something that you are very, very comfortable with by now. So the Pythagorean theorem, you have altitude squared plus you have the base of the triangle squared is equal to the hypotenuse of the triangle squared. So the altitude, I don't know. So I still have altitude squared. I know the base is 12. So I have to square 12. And this is going to equal the hypotenuse of 13 squared. So use your calculator. 13 squared is 169, and 12 squared is 144. If you subtract 144 from 169, your altitude squared is going to equal 25. Take the square root of both sides, and the altitude is now 5. So you take your pen, you go over to your triangle, and the altitude is 5. Now you know the cosine of A is negative 12 over 13, and now they want the sine of A, which is now going to be 5 over 13, because this is now the opposite to the hypotenuse. Now, for every single problem, every formula where it has an A, sine of A, you're dropping in 5 over 13. For this number 5, every sine of A is going to get 5 over 13. And here's the sine of A, it's going to get a 5 over 13. Here's the sine of A, 5, whoa, bad 5, over 13. And here's the sine of A. It's simply, once you use the Pythagorean theorem, you are dropping in your ratios. Now, the cosine was given, negative 12 over 13. Wherever there is a cosine of A, right here, we are putting in a negative 12 over 13. So guys, it looks intimidating, but it's nothing more than the Pythagorean theorem and then dropping in the numbers. And you can evaluate. I know you can. You have it. Whoops, that's a bad, let me fix that. I know you can. I have faith in you guys. You can absolutely drop these numbers in. So there is my negative 12 over 13. Here's the cosine A, negative 12 over 13. And notice I haven't even touched triangle B yet. So here, all my A's are A angles, the cosine and the sine of angle A are now put into all the formulas. Now I'll use a different color. Let's talk about B. B is in between 270 and 360. That means you are in quadrant 4 because this is 270 and this is 360. So you just got to take your time. I know you all can do this. And they give you the ratio, again, cosine, adjacent to the hypotenuse. So we draw angle B and make a right triangle. Here's B. The adjacent side is 4, and the hypotenuse side is 5. Now you have to find the opposite side, which is the altitude of this triangle. So you have altitude squared plus your base of 4 squared is equal to your hypotenuse of 5 squared. This is 16, this is 25. 25 minus 16 gives you your altitude squared is 9, making your altitude 3 when you square root both sides to solve. So get rid of the square by square rooting. So now your opposite side is 3. Okay, you know your cosine, they gave it to you. The cosine of B is this guy. Now they want the sine. Sine again, opposite is 3 over the hypotenuse of 5, and you are in quadrant 4. You went down 3. Going down 3 means negative. So now, just like with A, we know everything about B. We know the cosine, we know the sine. We come over here, cosine of B, we're multiplying by 4 over 5. Now these two guys were multiplied together when you're adding. And then the sine of B, which is negative 3 over 5, is being multiplied by the cosine of A. So now we dropped in the 4 ratios. Multiply both and then add them up. The same is true with subtraction. Here I have the sine of A was 5 over 13, cosine of B, multiply by 4 over 5. Going to multiply those two together, get an answer. Then I'm going to subtract from that the sine of B, which is negative 3 over 5. Multiplied by the negative 12 over 13. Get that answer, and then subtract the two answers. Over here, we're dropping in the cosine of B, positive 4 over 5. Again, you're going to multiply these two together, get an answer. And then you're going to subtract the product. Whoa, well, that's really bad. And then you're going to subtract the product of the A sign and now the B sign. Multiply, subtract the two, and then you get your answers for the sum of cosine. And now the difference of cosine, you have your cosine A, you need your cosine B, which is 4 over 5. And then you're going to add to that the sine of A, which was your 5 over 13, times your sine of B, which is your negative 3 over 5. So again, this entire thing is going back to the Pythagorean theorem and finding that missing side. And I know you guys could do the Pythagorean theorem. This has been something you've been doing in math forever. And we're not even giving you radicals on this one. You just have to, you know, a squared plus b squared equals c squared, and then you just have to drop those fractions into the formulas. So it really is pretty straightforward. Try to get past the way it looks. It looks intimidating, but just because something looks bad doesn't mean it is bad. This truly is a really, really nice lesson. Just breathe and give yourself a moment to relax and just take your time. You know, once you have each ratio, take each ratio, drop them in. You'll be fine. Because that's what they asked you to do ultimately for this problem, is they wanted all four of these. So if you took your time up here and just dropped them in one at a time, you got all the answers to C through F. Good luck.